Hello everyone, I'm back with my fourth video on Cisco's SD-WAN Viptela. Today what we are going to speak more on application-aware routing, which is one of the critical and important aspect to understanding software-defined wide area networking. Application-aware routing, also called as an acronym called AAR, which is one of the biggest magic which actually been done in software-defined wide area network, where you don't need to be reactive. Everything been done by policies with some intelligent monitoring aspects done by all the SD-WAN vendors, and it is actually transparent to the end user. Okay, so we will kick off with that particular presentation on AAR along with demo in my part 2. So part 1 will be more focusing on the following agenda. With we are going to see what is application aware routing and how it works in Cisco SD-WAN. What are all the key components on Cisco SD-WAN, which is called Viptela at the moment, and maybe we will go with a deep dive on how actually it works in deep dive, like what are all the timers and how the calculation happens. Final wrap up with the business benefit, what exactly application aware routing is going to give a benefit to our enterprise customer, and finally we'll wrapping up with a thank you. Okay, so let's kick off. So what is application aware routing? If you see, application aware routing is some way of intelligent mechanism to forward your data traffic across your WAN. It could be WAN, could be of multiple links, maybe of MPLS, internet or 3G, where you ensure that you have a pre-application performance metric or SLA class is defined. So what do you mean by SLA class? So what we say is that you actually defined an interesting traffic, which is actually mission critical for your enterprise. So it could be that that particular application always been given a priority and always ensure that it is actually given in right transport. So that means that you are actually mapping with some metric value at a service level agreement that this application should not get violated as per this particular performance metric. If it gets violated, then take a necessary action, and that should be seamless to an end user without even session break, right? So it's a basic definition on AAR. What we say that application network traffic, how it actually does is it actually tracks the network and path characteristics of the data plane between your edge devices. It could be edge devices, could be in Cisco's world, I mean VH or other symmetric SD-WAN devices, right? So it is actually, I mean, it is actually tracking the network and path characteristics. It could be jitter, it could be delay, it could be, anything you can say, latency, etc., and other stuff. So application aware routing is more than what we do in dynamic routing protocol. Like we load balance the traffic between the links with the help of your metric or hop or any other stuff you can think about, right? So it actually does much ahead of that. So, I mean, standard topology, what I want to say, what we have described on these 2 points is you have two branches and data center, and they have the connectivity with full mesh with MPLS and stuff. And the connectivity happens that you want to access some mission critical application host from branch. So how the things happens. So actually, normally happens is the internet links or the MPLS link, the transport, when they actually come up, the data plane come up, it could be an IPsec or MSec or whatever the overlay it has been done, right? So most of the SD-WAN vendors, they do their own mechanism of gathering the characteristics. So most of the vendors normally use BFD. So BFD uses, or BFD actually, the BFD packets runs between your point-to-point boxes, which gets and captures your round trip time, which actually helps to calculate your packet loss or latency and jitter and the load or etc. Right. So application aware routing actually simply calculates all those things what BFD has actually gathered for it. So that's why you can simply define as application aware routing. It just is a policy based automation of performance management. You understand what the definition is? What I'm saying is you are making routing as an application aware. So what that means is routing is done intelligently based on the application need. So you are actually maintaining the service level agreement that this particular application is required to be maintained with certain SLAs when it is actually running on a data path on your network. Okay, So you can see with some animation that primary path is this. If primary path goes or it actually breaches an SLA, then you automatically switch over to the secondary path without even intervention of any user or network administrator or any alarm. So it is seamless. So overall, this particular slide speaks about what is application aware routing, right? Which is one of the critical point or critical aspect or critical use case in software defined wide area network. Okay, so let's go on to the next slide where we speaks about how it works with Cisco's SD-WAN. So how normally Cisco's SD-WAN happens, there are three main components. In order to do an application aware routing in SD-WAN with Cisco, you first need to identify. So what is your interesting application, and you need to define certain SLA along with that. So if I say SLA means SLA is some sort of metric value you are binding. So let's suppose, for example, if I say you have a mission critical application of voice, right? You have selected that this is your interesting application, and you have maintained and binded that this particular application should always prefer a primary path of MPLS because of its nature of availability, and that MPLS should be binded with certain SLA, like it should not exceed 2 milliseconds of latency, or you say that it should not have more than delay of 50 milliseconds, or you say that the jitter should not be of 2, something like that. So those are the SLA metrics which have been binded with an application, and based on those particular SLA metric which is actually binded on your transport link, and the magic actually happens automatically between the boxes because of the automatic intelligence what they share called BFD. The BFD actually polls all the polls the health of the transport medium, so that AAR uses a application aware routing uses the BFD's collected information to do certain action without even intervention, right? So second part is about the monitoring and measuring. As I said, BFD is a mechanism which has been leveraged by Viptela or Cisco SD-WAN, if I say in today's world, which normally monitors the data traffic and measure the performance of the tunnels. Why I'm saying tunnel is because that is where the data traffic is actually flowing. It's a secure. So it's an IPsec tunnel, and BFD actually measure the data traffic on the tunnel and actually collect the performance of all the packets which are flowing between your BH devices. And Viptela software which actually look for the traffic loss or latency which are been measured or which has been collected by the BFD, either it's one way or round trip time, or the traffic leaving over the tunnel, something like you can call, right? And finally you map the application traffic based on what are the collected information from the BFD. So Viptela software normally do a calculation of average base, what is the packet latency or packet jitter or the delay, and is it matching the SLA metric which is binded with the critical application. Then based on that, it automatically takes and map the application to a required transport based on certain two criteria, which could be like the best path criteria for WAN performance or specified by some policies, what we are saying as AAR. So let's see some animation how the things happen. So maybe you can say with two branch networks which are connected with service provider and over an IPsec tunnel, traffic actually flows like this normally. So based on the things that once the BFD packets are to and fro and stuff, so it actually gets collected on VH routers. Okay, so let's see some of the interesting part of how it actually works on a deep dive. Majorly how the calculation happens and what all the things happens behind the screen. So how it works. So first the classification of tunnel happens. Let's look at this on a deep insight how the classification of tunnel happens is. Right. First, most point happens is how the measurement of loss, latency and jitter, which are the key SLA metric, what we defined on the transport medium, and how it happens is. Let's see that. So you have branch locations, maybe branch 1 or branch 2 on the left and right, and you have one service provider which is having a data plane connectivity with the IPsec tunnel, and which actually has the full-fledged connectivity between the two. And your first BFD packet flows from your branch 1 to branch 2. Maybe it's a round trip time or one-way time, and this BFD packets get collected with the logs of loss and latency and jitter on that particular tunnel, right? And the second one also comes with another same pattern, and which also give you the same stats of loss, latency and jitter, like in the third one, right? In Viptela architecture, the BFD packets are by default of 1 second. Okay, so you can say the BFD session or the BFD hello packet interval, it is of 1 second by default. You can tweak that, but better recommendation to have 1 second, because you can have an accuracy of what the health of the transport link is been actual better for your application performance. And BFD session automatically starts. It's a by default nature of Cisco's SD-WAN architecture. Once the data plane tunnel comes up over the overlay, automatically VH routers are enabled with the BFD session. So your data polling of BFD packet starts, and VH routers start pumping the information of all those BFD information to measure the loss, latency, and jitter automatically. You don't need to do anything actually. And AAR, which is application aware routing, where you actually define some policies, intelligent policies, I would say, which is actually benefit for your enterprise customer, uses this BFD hello packets, because BFD packet is actually been running automatically without your knowledge also. I mean, it's just taking the feed and just getting the information of the transport health, and AAR with the policies of the SLA metric, what has been measured or what has been asked to do as a reaction. It uses all these BFD hello packets, and based on that, it actually do the reaction or the action, I would say an action of an SLA class, what it need to do, whatever you have actually collected with the help of BFD, right? So let's go to the next one. What happens is, we have done the measurement now. So you have collected the measurement of, or the health of your transport. Maybe I would say the measurement, you would say in the health of a transport, that how healthy is your transport link is. How? With the help of BFD packets, which is flowing between your devices every 1 second. Okay. So next part comes about your calculation, which is one of the best thing which happens. On what basis the health is poor or better or the best, you decide the calculation of loss, latency, etc. So BFD normally, it actually polls the VH router periodically, right? So as I said, because of its nature of 1 second, so it's actually polling for every 1 second between your devices, and the poll interval, what you say, is actually a bucket in Viptela, I mean in Cisco's SD-WAN. So application aware routing, it actually calculates the average. Why I'm saying is average, because the poll interval I said as a bucket, right? So it's a bucket of 10 minutes. So if I say 10 minutes, you can think about that BFD packet, which is of 1 second, each and for every 1 second, you are actually sending a BFD packet between the devices. So for 1 minute, you are having a 60 packets, correct? And what about then in 10 minutes, it's 600 packets. So 600 packets are getting stored in a virtual bucket, which is called as poll interval. Understand? So what happens is, on this 600, I mean, after 10 minutes, you get one poll interval. So by default, there are 6 buckets are preserved in this particular BH router. So if I say 6 means 1 hour. So 10 minutes for one bucket, which is having an all data calculation and gather for almost 600 packets, right? And the same then it happens for another 10 minutes, which is called bucket 2, which is called, then it actually have the data for 20 minutes, then third bucket for 30 minutes, then 4 for 40, then the fifth, something like that, 10 10 10 10 20, then you can say 10 10 plus 20 20 plus 30 30 plus 40 50 and 60. So if you see the 6 buckets, which is of 1 hour, right? So what happened to the 7th bucket? When the 7th bucket comes, or the 7th interval, poll interval started, right? So normally happens as an intelligent that the earliest bucket get discarded. So what do you mean by the earliest bucket? The first bucket, which was taken on the initial at the beginning of the starting of the BFD hello packet. Understand? So that particular bucket is get discarded. So you always have the latest information, that is bucket 2, 3, 4, 5, 6. Again, one comes as bucket 7. So the beauty of this is you always have the latest real-time information which is being used to calculate the average by these buckets or the pole interval. I mean by AAR, which calculates the average with the help of this BFD packets which are stored on these pole intervals, which are called buckets, to get you the actual and the best and the realistic performance or the health of your transport, which is best suited for your enterprise applications. Okay, so you can see how interesting is how the overall concept happens is. So normally we speak that, so we normally map or measure the loss latency data. What I'm trying to explain you that how it has been done at a low level, and what is the key core concept which actually help us to do all this is BFD, and how AAR uses BFD with pole intervals and the BFD packets, and how the magic happens is that we are going to see in our next video on part 2 on a live demo how things happen. So this particular video mainly speaks about the overall concept, how the application of a routing is influencing SD-WAN because of all these technical stuff what I'm saying at a low level. Okay, so let's see some animation whatever I have thought so far and what I'm saying. Actually, you have two branches and you have some providers. Maybe I'm just taking one service provider here, and you got an IPsec tunnel. Then the magic start. So you get a BFD packet every 1 second, I say. So the BFD is going from to and fro from your branch 1 to branch 2. Then it actually ends up in your whole interval, which is a logical bucket, right? So I'm just taking one BFD, you can say as an, so every 10 minutes one bucket is actually being spawned, so you will get 10 BFD packets, right? So once the BFD packets been captured on pole interval 1, so assume that it as if like that pole interval 1, 2, 3, 4, 5, 6, and the 7th pole interval comes live. So what happens? So once the 7th interval comes live, so the pole interval bucket 1, which was your bucket 1, gets discarded. Then the same pattern happens every 1 second. The BFD is actually going to and fro to measure the real health of your transport, so that your application aware routing is working as expected without even any flaw. Make sense? Good. So I mean, this is what the whole story, like how the things happen with application aware routing, and how intelligently it actually giving you the realistic awareness of your transport medium, that this is best for my mission critical application, and the other transport is best for your backup link, and let's see the health. So which is not feasible in today's world if you think about the traditional WAN routing. And you can do to some extent that with some IPS SLAs and stuff, but those are very cumbersome in terms of configuration, and you need to manage and react, and all those things happens, right? So that's the beauty and power of SD-WAN comes. You don't need to do anything. Once the boxes come and connect in your SD-WAN topology, IPsec tunnel automatically comes up, BFD automatically comes up. It's just a matter of just creation of policies. And policies uses all this intelligence and algorithm what has been developed by or leveraged by the vendors, so that you can easily configure, manage and monitor, and as well as in case of any brownout issues or in case of any service provider issue, you don't need to worry. Everything will work as if like a charm, that you don't need to worry and bother about users SLAs getting met or not, because these intelligence or application aware routing, that's why it is called application aware routing, it automatically take care what it need to do without even your intervention. Okay, so what are the business benefits with application aware routing? I mean, so far what we thought what we have seen is what do you mean by application aware routing, and how it actually influences SD-WAN, and how it works on a deep dive with how the measurement happens, how the packet flow happens, or how the overall calculation happens, and what it actually does, right? So what exactly it's the business benefit giving to your enterprise? Number one is an uptime. Uptime in terms of service availability. If I say improve service availability, so what does that mean is, what I'm saying here is service availability for your application. what happens in today's world is, if you're not having any intelligence in your SD-WAN as a proactive way of transferring the application over some other transport medium intelligently. So normally happens is, if you are running an application over an MPLS, and if something is having a problem on your service provider end inside the provider's network, it will never be an issue with respect to an outage of an application. It will always be a degradation in performance, right? Because of the brownout issues. And availability or the service availability to your end user will always be an degraded. So the improved service availability point makes sure that application aware routing intelligently decide what is the best path to meet the SLA for that application so that user is always happy. So that's why we say that it actually gives you an uptime with respect to service availability. Okay. Second point is the performance. Enhance application performance, because enhance application performance is the health of a transport medium is continuously measured, and we are measuring all the parameter TSLA metric like loss, jitter, delay, even the bandwidth, or you can say any other load also been getting measured, so that proactively, so that what I'm saying is you are proactively doing the changes or movement of your application traffic on the best available link without even intervention or without even reactive that user is shouting on the other end and you don't know. Even you have a lots of monitoring tool, but it still become a reactive. So it is become a intelligent based routing that you don't need to worry. Everything is done based on the policy what you have defined for the application, what is defined as a critical by your enterprise world. Okay. The third one, cost. Why I'm saying is the cost is become reduced because you are effectively using both the internet or both the MPLS or hybrid internet or MPLS links. What happens in traditional world is you never use both the transport link very efficiently. One will be heavily loaded, and you will be still paying for the other link, which won't be having that much load. And what I'm end up is, because of not having any intelligence on your transport medium, you would be actually upgrading the bandwidth. If at all, if the primary or secondary link just getting pumped, because the user traffic is actually blindly sending on those particular link with just PBR based concept or with some telemetry analysis you are doing, right? So what happens is nothing need to be done now. So because of the intelligence of application aware routing, and the health is getting checked very frequently with some very short time intervals, both your links are efficiently used. So you can think about that the bandwidth cost which you are actually blindly increasing in your early days, you don't need to do right now. Because still the bandwidth will be increased not to an extent, but to small extent with a valid and justified reason. Yes, you required a bandwidth because of your increment happened and the load is getting and the user strength is getting, rather just saying that okay, I'm just pumping out some traffic on some primary link, oh it's 99% getting increased, I just need to upgrade. So you're efficiently also using both the links. So you can think that if you're having a primary link of 2 Mbps or 10 Mbps of primary link and a secondary link of 5 Mbps, if only primary link gets utilized, so we are just pumping out or just increase the bandwidth upgradation for the primary link. Rather, we never focus on secondary link. If at all we do load sharing or load balancing, okay, so we never used to think that are we actually load balancing on the right methodology or not. I mean, is the packet or the application traffic is really required that particular transport link. So that's why I'm saying as a reduction in cost because of an intelligence what we have developed with the help of application aware route. The final piece is reliability. So with reliability, what I'm saying is links reliability. You get to know the links, how much they are reliable. So you don't need to worry about the link will work on this particular day and time if it is a mission critical time for you. Because of this intelligent and the immediate pollings which have been done on this particular link, and based on that SLA is getting binded and SLA class is applied on these particular mission critical policies. So you don't need to worry, everything will be taken care by all this intelligence which has been done on this particular application of our routing, which helps to achieve our service availability of the application or making happy of user because their performance gets high rated, or users get a high value in order to access the application because the performance is met, and the link reliability also automatically comes into picture because of this intelligence algorithm, or you can say some intelligence routing or some intelligence data capture. Based on that, the decisions are being made. So these are the direct benefits, business benefit you can think, which actually been running on top of the technology, which is one of the feature or technology called SD-WAN, under which application aware routing is one of the key pillar. Is one of the key pillar which is actually helping out to make your mission critical application safe on any of your transport medium, or maybe on a commodity based transport medium, with actually achieving all these major four business benefits. Okay, so with this I would just like to say thank you, and I would love to hear from you in case of you have any queries or doubts with respect to application aware routing, uh, and so that we can discuss more and we can think about what all the new topics we may need to discuss, or what all the major feature or use case you want to think in SD-WAN use case. We are still open to talk. So finally I would say thank you, keep watching and subscribe this video for more talks, and be ready for the part 2 for the live demo for application aware routing. Thank you very much.